Welcome to this tutorial on infrastructure as code with Terraform Basics. This is part of our Cloud Infrastructure as Code series. In this video, you'll learn the fundamentals of Terraform, one of the most popular tools for managing cloud infrastructure through code. Whether you're new to DevOps or looking to automate your infrastructure, this tutorial will give you a solid foundation to get started with Terraform. Let's start by understanding what infrastructure as code actually means. Infrastructure as code, commonly abbreviated as ISC, is the practice of managing and provisioning infrastructure through machine-readable definition files, rather than physical hardware configuration or interactive configuration tools. Instead of manually clicking through cloud consoles or running commands one by one, you write code that describes your entire infrastructure. This code can then be executed to automatically create, modify, or destroy infrastructure resources. Think of it as transforming infrastructure management from a manual process into an automated, repeatable workflow. Infrastructure as code brings several powerful benefits to your workflow. First is consistency. By defining infrastructure in code, you eliminate configuration drift and manual errors that often happen with manual setups. Second is speed. You can rapidly deploy and replicate entire infrastructure environments in minutes instead of hours or days. Third is version control. Just like application code, you can track every change to your infrastructure, see who made what changes, and roll back when something goes wrong. Fourth is reusability. You can share and reuse infrastructure templates across teams and projects, saving time and ensuring best practices are followed everywhere. Now let's talk specifically about Terraform. Terraform is an open-source infrastructure as code tool created by HashiCorp that enables you to define and provision infrastructure using a declarative configuration language. What makes Terraform special is that it's cloud-agnostic, meaning you can use it with AWS, Azure, Google Cloud, or even on-premises systems using the same workflow. It's provider-based, which means it works through plugins that connect to different platforms and services. And it's declarative, meaning you describe what you want your infrastructure to look like, and Terraform figures out how to make it happen. To work effectively with Terraform, you need to understand 4 core concepts. First are providers. Providers are plugins that interact with cloud platforms and services like Oz, Azure, or Kubernetes. Second are resources. Resources are the actual infrastructure components you want to create and manage, such as virtual machines, databases, or networks. Third is state. Terraform maintains a state file that tracks the current status of your infrastructure, allowing it to understand what exists and what needs to change. Fourth are modules. Modules are reusable configuration containers that let you package and share infrastructure configurations across projects. Terraform configurations are written in HashiCorp Configuration Language, or HCL for short. The basic syntax is straightforward. You define blocks using a resource keyword, followed by the resource type in quotes, then the resource name in quotes, and then curly braces containing the configuration. Inside the block, you specify arguments as key-value pairs. You can also nest blocks within blocks to define more complex configurations. The syntax is designed to be human-readable, while still being powerful enough to describe complex infrastructure. Working with Terraform follows a consistent 4-step workflow. Step 1 is init, short for initialize. This command initializes your working directory and downloads the necessary provider plugins. Step 2 is plan. The plan command previews what changes Terraform will make to your infrastructure before actually making them. Step 3 is apply. The apply command executes the plan changes and creates or updates your infrastructure resources. Step 4 is destroy. When you're done with resources, the destroy command removes all managed infrastructure. This workflow ensures you always know what will happen before any changes are made. Let's look at a practical example. Every Terraform configuration starts by defining providers. In the Terraform block, you specify required providers. Here we're using the Oz provider from HashiCorp with version approximately 5.0. The tilde greater than symbol means Terraform will use any 5.x version. Then in the provider block, we configure the Oz provider with specific settings, such as which region to deploy resources in. In this case, we're using US East 1. This setup tells Terraform which cloud platform to work with and how to authenticate. After defining the provider, you define resources. Here's an example of creating an AWS EC2 instance. The resource block specifies the type as Oz_instance and gives it a local name of web_server. Inside the block, we set the AMI, which is the machine image to use, and the instance type as t2.micro. We also add tags, which are labels that help organize and identify resources. The name tag identifies this as my web server, and the environment tag marks it as development. Once you run Terraform apply, this code will create an actual virtual machine in AWS with these exact specifications. State management is a critical concept in Terraform. Terraform stores information about your managed infrastructure in a state file called terraform.tfstate. This state file serves three important purposes. First, it maps real-world resources to your configuration, so Terraform knows which cloud resources correspond to which code definitions. Second, it tracks metadata and resource dependencies, understanding the relationships between different infrastructure components. Third, it should be stored securely in remote backends for team collaboration. Never commit state files to version control as they may contain sensitive information. Instead, use remote backends like AWS S3 or Terraform Cloud. Let's review the essential commands you'll use regularly. Terraform init initializes your working directory and downloads providers. Terraform validate checks your configuration syntax and consistency without making any changes. Terraform plan previews infrastructure changes before applying them, showing you exactly what will be created, modified, or destroyed. Terraform apply creates or updates infrastructure resources based on your configuration. Terraform destroy removes all managed infrastructure resources when you no longer need them. And Terraform FMT formats your configuration files to a standard style, making code more readable and consistent. These 6 commands form the foundation of your daily Terraform workflow. Let's recap the key points from this tutorial. Infrastructure as code enables you to manage infrastructure through code instead of manual processes, bringing automation and consistency to your operations. Terraform is cloud-agnostic and uses a declarative approach, meaning you describe what you want and Terraform handles the how. The core workflow is simple. Initialize with init, preview with plan, execute with apply, and clean up with destroy. And remember, state management is critical for tracking resources and enabling team collaboration. With these fundamentals, you're ready to start building infrastructure as code. Practice with small projects, experiment with different providers, and gradually expand your skills. Happy building!
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.